So if you ever wanted to add a receptacle to a room that for whatever reason, either it doesn't already have receptacles in them, but you don't want to go through the hassle of cutting a hole in the wall, adding a box, fishing wire through the wall. Well, in this video, I'm going to show you what is quite simply the easiest way to add that accessible receptacle. It just has to have one component in that room in order to make it work. So let's go ahead and jump right in. Let's go. So I'm here in front of my mock-up wall that I made up to give you guys an example of how I go about doing this. Now what I do have here is I have a light switch and I have a light, and I do have power flowing through the light switch in order to operate that light, to better give you guys an example or a real world scenario of how I go about doing this. So that key component that I talked about in the introduction a little bit ago that you're going to have in the room in order for this install to work is in fact this light switch. The other thing is we're going to have a neutral wire in that switch box in order for this install to work. Now the first thing that I want to do before I start messing with any of the wiring is I want to turn off the circuit breaker that's supplying power to the light switch. Once the circuit breaker is off, then I can take my voltage detector and check to make sure that the power is in fact off going to the light switch. Now that I've verified that the power is off, now I can pull the switch out of the switch box and disconnect all the wires from the switch. All right, so as you can see, I've got my ground wire removed from the switch. I've got my two black hot wires. One's gonna be line, one's gonna be load, removed from the switch. And in the back of the box, which is where they're almost always gonna be unless you had a smart switch of some sort, is going to be the white neutral wires. So we're actually going to be adding the receptacle here at this switch, and we're going to do that by installing this device here. This is a switch receptacle combo. It is tamper resistant, which boo, I know we all can't stand those things because they can be a real pain in the butt, especially for kids. They can't stick things in them anymore. But in most places, this is going to be required per code to have that. It's just this simple. We have the light switch here, which is going to operate the light that is installed in the room. And we're going to be adding this single receptacle so that we have a receptacle that is accessible as soon as you walk into the room. But before I can start wiring all this up, I need to figure out which one of these black wires is my line and my load. So I'm going to have to turn the power back on briefly, but I'm going to need to know which one of these is the line and the load, because on this particular switch receptacle combo, there is a particular screw that the load wire goes on, which for those of you that don't know, your line wire is the wire that is bringing in the power that is supplying the feed from your breaker panel, and the load wire is the wire that then goes on to the device that you're trying to power through the switch, which would be in this case a light fixture. So I'm going to go ahead and turn the circuit breaker back on. So I'm going to take my voltage detector and figure out which one of these is the hot wire. So I'll check my ground to this first black wire here. No power there. To the second one. And there you see they've all illuminated up. So my hot line wire is the bottom wire, and my load wire is going to be this top black wire. Now I'll turn the circuit breaker back off so I can work on everything. And then once that's off, I'll use my voltage tester again just to make sure that the power is in fact off again. All right, so to get started with installing this switch receptacle combo, I'm going to start off with installing my ground wire, which is this bare copper wire here, and it's going to go around this green ground screw here on the side. So I want my loop to go around the green ground screw in a clockwise direction. So I'm just going to put it on there. Wrapping it around in a clockwise direction promotes pulling the wire in closer to the terminal screw itself. Instead of if it was counterclockwise, it would actually want to kind of push it away as I turn and tighten that ground screw down. All right, so the next terminal screw that I want to connect to is this silver and color terminal screw here. And this is where the neutral wire is going to go. But as you saw, there's no neutral wire that's free that came off of the old switch. Single pole switches do not have a neutral wire on them. The neutral wires are just tucked into the back of the box connected, which is going to the light fixture and then from the feed wire. But for smart switches, and for instance this switch, since it has a receptacle on it, I'm going to have to get a neutral wire coming from these neutrals here. And that is very easy to do. All I'm going to need is a pigtail that I've made up here. So I'll go ahead and take the wire nut off of these neutral wires. And if you're not completely sure what a pigtail is, I've got a video on the channel that I'll link at the end of the video that you can check out. All right, so as you can see, my neutral wires are already twisted up. So since they're already twisted up and they're a little bit marked up, I'm going to go ahead and cut those off. And then I'm just going to strip off some more insulation so I can get to some fresh copper on these wires. So then I'm going to take those two neutral wires, put those together, and then I'm going to take my pigtail and put it up together with those other two neutral wires that are already in the box. And then I'm going to twist my wires together. Then once those are twisted together, then I'll take a new wire nut and put it on top of those wires and tighten it down. So once those are all twisted together, I'll take the wire nut and the wires and push those into the back of the box. But of course, leave this end of the neutral wire pigtail out of the box to connect to the device. All right, so over here is going to be where the neutral goes, where the silver colored terminal screw is. But what's nice about this particular device and your commercial grade devices is instead of having to wrap it around the terminal screw, it's not backstabbing, it's called back wiring, where you see these holes here. We'll push the wire into those holes. That plate will then be tightened down on top of the wire and basically sandwiching that wire in between the plate and the device itself, so that then the wire is making some really nice contact and the wire can't just be pulled out. And then once I've confirmed that the wire is underneath of that plate, I can go ahead and tighten down this terminal screw. Give it a pull, and it's in there nice and tight. All right, so the next terminal screw that I want to connect to is this top gold or brass colored screw. And this is going to be the terminal where the load wire goes, which we determined is this top wire here. But before I do that, I'm going to go ahead and cut these hooks off of the wiring and start with new wire again. Hey, really quickly, if you're finding value in this video, if you could do me a huge favor, hit that thumbs up button right down below. It really does help the video out to help and spread out to other people and hopefully be able to help them out with this as well. I really appreciate it. Let's get back into it. And if you're ever unsure as far as how much insulation to remove from the wires, pretty much all of the devices that you're going to install, receptacles, switches, this device, if you turn it over here to the back, you see this line down here? This is a strip gauge. It's telling you how much insulation needs to be removed or how much copper needs to be exposed in order to fit that device properly. All right, so now I'm going to take my black load wire that's up here on top, and I'm going to put it in underneath of that plate, underneath of this brass or gold colored terminal screw. Then once that wire is seated in place underneath of that plate, then I will tighten down the terminal screw. And so the last wire I have is the line wire, and it can go underneath of either one of these black screws. Now the reason there are two of these is because you can still make this a switched outlet if you wanted it to be. But if you want to leave it to where the power is just flowing through it all the time, then you'll just leave this little bar that's connecting these two terminals together. The wire can go to either one of these terminal screws, whereas if you were going to make this a switched receptacle, then you would break the bar off, you'd connect the wire coming from the switch to the lower screw here, and then the wire that has power flowing through it at all times to this screw up here. But again, in this case, it really doesn't matter which one it's going to because it's going to have power at all times. I'll go ahead and tighten down the terminal screw. And then, even though nothing is going here, I want to make sure that I tighten this screw down as well. This way it's not just sticking out and could possibly make contact with something we don't want it to. And now I can push all the wires into the back of the box. And then once that device is set into place, I can then tighten it down into the box. Now one thing to note, if this was being installed into a new work box, which is one that was already in the wall, then you would not need to remove these tabs here because these tabs are what's going to actually be setting up flush with the drywall or the wall itself. Whereas with this old work box in here, if I leave these tabs on, it's not going to fit down into the old work box like it's designed, and when I go to put my cover plate on, it's not going to sit completely flush with the wall. All right, so now that everything's installed, now the circuit breaker can be turned back on to test everything. So the first thing that I'm going to test is going to be this receptacle, and I'm going to do that by using my outlet tester. If everything is wired up correctly, these two lights will light up. And there you go. So now I know that the receptacle works. Now I need to test the light switch to make sure that the light fixture still comes on. So all I have to do is flip the switch and the light comes on. So now I know that everything is installed correctly, and now I have a receptacle where I didn't have one before. Now one thing that I want to add really quickly is to make sure that you always check with your local building department and make sure that you're following all of not only the NEC codes, but also any local codes that they may have as well. In some places, they may not allow for receptacles and, for instance, your light switches and your light circuitry to be on the same circuit. But if you like other electrical projects, I've done a bunch of them in the past. I'll post some right over here that you can click on, and it'll take you right to them if you are interested. So I hope that this was helpful. If it was, if you could do me a huge favor, hit that thumbs up button right down below. And of course, if you have any questions or comments at all, you can leave those down in the comment section. I'll catch y'all in the next one. See ya.